Alright, welcome to another video lecture. This is going to be 6.4, which is talking about equations with squares. So before we start in on the examples, what I need to do is give you a little bit of a definition. So this is talking about the square root property of equality, and that is if two positive numbers are equal, then their positive square roots are equal. And I always like to do it there, that is, for this sort of thing. And so that is for any real numbers, if a equals b, then square root of a equals square root of b. So why is this important? This is important because we're going to be able to use this to solve certain equations where we're going to have squares that we wouldn't otherwise know how to do. So we're going to start with an example. Why don't we have this before? So if we had an example of something like x minus 3 squared equaling 25. That's a little messy. Let me write it again. X minus 3 quantity squared equaling 25. So if we had something like that, where would we even start? As of right now, you wouldn't have any tools to be able to solve this sort of an equation. But from what we just learned, we learned that if we have two numbers that are equal, then if we take the square root of each one of those numbers, then that's still equal. So we want to maintain equality. So far we've learned a whole bunch of properties of equalities that lets us do certain things to equation to keep things equal. Well, the same thing here. So now we've learned we can take the square root of each side, okay, so if we've taken the square root of each side, now what we can do. So we learned so here's where something tricky comes in, and this is kind of off to the side. Before we kind of talked about, we had the example where we took the square root of x and we squared it, and we said that that was equal to x. If you remember that, that was in one of the lessons. And this is, of course, for any x greater than 0. We can't take a square root of a negative number yet. So this is true for anything x greater than 0. Well, now we're going to have the opposite situation where we're taking x squared and we take the square root. And what do you think that is going to be equal to? So that is a big difference. And the reason we've been learning about absolute values is because we're going to say it equals the absolute value of x. This is something that's a little bit more complicated because this doesn't necessarily make sense. If we took, let's say, -5 and we squared it and took the square root of it, what do you think that would be equal to? Well, our instincts might say, oh, if we just take the square root of x squared, it's just going to be x. But in this case, if we square -5, we get positive 25, and if we take the square root of positive 25, we end up with 5. So this is the reason, that's kind of an example to show why this terminology will make sense. Back to this problem, if we look at where we are here, anytime you have a variable, this is what you're going to end up doing with it. So you take whatever is the inside, because here the 3 is going to be associated with the x. So you're going to have the absolute value of x minus 3 equaling, and what's the square root of 25? Well, from here we know the square root of 25 is 5. Okay. When we're left with this step, here's where we have to solve using absolute values, and I wanted to do an example where we showed an absolute value solving, because that is sometimes trick people up as well. You can do it one of two ways. The way that I prefer is that you take the original one without the absolute value, and that's one of your equations. And then the other thing is you take the negatives, you times the inside of this by -1. So you get -x plus 3 equaling 5. Okay. As another side note, I'll just mention that some people might have taken x minus 3 and set that equal to plus or minus 5, and that's okay too, and is allowed, and is by definitely all means legal. But I like to use this process because it reminds me that I'm going to have two separate equations. Sometimes with this, it looks like one equation, so you're just going to keep it as one solution. But really, you need to make sure that you understand the solution set to this kind of problem has two solutions. Okay. So if you look at this one, then you just solve like normal. So when you move the 3 over, you're going to get 8. And for here, you're going to have -x equaling you minus the 3 over, so you have 2. And so x equals -2. And so either one of these solutions is now acceptable for this problem.